Okay, so let's make a comment here. Even though I comedically pressed the on button on my phone, I figured the video was sufficient. Now notice how it doesn't have everything on there. So we have completely instead of comedically. So, but let's say I didn't notice that and I pressed enter there, okay? Now I'm gonna go in here and I'm gonna edit this. Nope, it's the other one. So I'm gonna come in here, I'm gonna edit this. Okay. Okay, now let me update that. Okay, so now it says edited. So now I need to copy, but notice I can't copy because we got an Android. So when I hold it, it's trying to like or do something else. So I'm gonna have to go in here and I'm gonna have to edit, and then I'm gonna have to hold my finger down. I'm gonna have to press select all, then copy. And notice how every time it loads the little thing, there's a delay, right? So I need to do a job where I have to edit about 100 comments per minute. Notice how I'm already on 1.5 minutes. So here we go. Now we're gonna discard. Okay, we're gonna delete that. Okay, now I can't press anything down here to comment a new one. Oh, there we go. See? So I had to wait on that, and then I had to wait for this to come up, right? Now I have to hold it and wait to paste, right? Now, even though I want to erase before this even, it selects like the wrong button. So here we go. See? And that's how long it takes. Now, imagine that instead of taking 2 minutes, it only takes me about 2 seconds because everything would be instant. There would be no delay. And you would still would have full animations. Everything would still look smooth, everything would still look animated, but none of the animations would slow anything that you're doing down. That's how I would design my operating systems. And on top of that, my operating systems would be better than just formally verified code, because formally verified code is just limited to programming languages, and programming languages is not formally verified to be proven to be the way to construct software. Actually, the best way to construct software is by verified transformations of a formal system, which means you don't write out a really complicated program. I was editing a program in F#, which is a very terse language. It's not like C. It's where if you take the cursor and you select one of the variables, the variable itself has a really complicated type, which itself is using a whole language just to define what the type is of that one variable. And I was trying to edit code for a professor one time, and it was a huge, complicated mess. And I was thinking, well, what if I used parse tree transformations to edit this code instead of trying to edit text and then have a compiler do that? And 5 years later, I worked for a company that I thought would be able to introduce this new concept to the world, because they invented a formal verifier tool based on a logic system. But then they said, oh, but it allows you to edit to verify any programming language you want. Programming language, but that means that you have to still edit it in text. So I tried to open my boss's mind up to this, but I think he just assumed that if your language has parentheses or something like that, then, well, you're just stuck, because it's mathematically proven that you can't have like a minimum number of parentheses in an easy algorithm or something, which doesn't matter because I'm not running an algorithm to minimize parentheses in a non-parsed tree. I'm just editing an already parsed tree. So we can rebuild computer software from the ground up, all the way from assembly language up, we can make everything above assembly, anything higher level than the machine itself. We can do all of that. Each stage, we can build the next stage using only tree editing tools and no full stack compiler. And by that, I mean no compiler stage that takes an entire program and has to run a parser on the entire program at once. So that stage of the compiler is no longer, that we don't need it, because you can edit software just by manipulating parse trees according to transformation rules. And I made a proof of concept of this. I made an app in 2014, and it lets you code just using menus. And I have videos of it because I didn't want to keep it on the App Store. I just didn't have the resources just to keep paying for something to be on the App Store that people weren't even using or downloading. Although it seemed like somehow 1,000 copies in China got downloaded all at once. I don't know how that happened, but it's kind of strange. But you guys can check out the videos and see how you can edit code, and that I don't even need to prove that a syntax error is impossible, because there's no stage of parsing to exist. So the syntax, you can't create a non-parsed tree because you're just editing a tree. So therefore, there's no way for the context of a syntax error to exist. There's no context for a syntax error to exist in the first place. So therefore, there's no such thing. I couldn't even define what a theoretical syntax error would even look like. So they can't exist. There's no such thing as a syntax error. You can try to create a parse tree that's not the structure that you wanted, but you still created it. And you can also try to, there's other things you can, logically your code can be wrong, but that's a semantics issue. And you can have the types. Point is, it comes into play that the type checking makes things more complicated, but that's where you can edit code that you usually wouldn't be able to edit before, like Lisp or F# or Haskell or anything based on like the Lambda cube. You would not have to manually try to get these types to match up, even if they're complicated. And that's what's really cool. That's what's really cool about it. You don't have to worry about manually keeping these stages, having to manipulate on one stage, thinking about how it's going to be compiled on another stage. You can keep them separated. And that doesn't mean that you're prevented from creating systems that would also do things like the creator of C++ would make sure that his system did, which is to use libraries efficiently that are already compiled or that will be compiled in the future without having to compile them all together. You can still have functions that have that work like that, because it's all about how you create your underlying type structure. And as long as everything matches correctly at the right level of abstraction, you could have things that are all assembly, all machine code already, but that because of how the functions are structured, it's all dynamic. It reminds me of a Steve Jobs long lost video that only a few people go and actually see, but he's showing how you can manipulate dynamically on the fly what's being done. So it's all about dynamics. But yes, you do have to keep everything Bjorn Starstrup, everything he talks about with C++, you always have to keep that in the back of your mind. You have to remember it's more complicated and it's more difficult than what people make it out to be. You don't just have a simple solution to a problem and say, this just works automatically, suddenly for everything. There's a lot of research and a lot of things that go into it, but there are solutions. And you have to keep that in mind. There are solutions to problems that engineers usually like to think, no, it's either one or the other. Well, there are third solutions, but you have to break down your initial assumptions, like programming language with the compiler. You have to break down those assumptions. When calculus of constructions was created, they had to do a lot of math research to figure out how do we make a more sophisticated version of this, use lambda calculus, but make it so that it normalizes no matter what, and it's still expressive. It still covers all our types. That's what they did. And that was in the 80s. And people still don't understand it. They still don't study enough to learn about this stuff, but they don't realize how powerful it is, how useful it is. But we have it. We have the math there. The math is there, just the understanding of it isn't there, and the actual products and things built on it are not there. But the way we go about creating things, it should be scientific. When we create a user interface, when we create a volume control, it sounds simple. It sounds like, yeah, it's just up is up and down is down. It's complicated because you have to have a master volume, and then you have to wonder, am I going to turn on my notifications volume? If I want to turn that down, does my master volume affect that? Is it one is a subset of the other? What if I'm trying to control the volume from a headset? Is that controlling the volume that the phone is giving to me, and the volume on the phone remains the same, and then my headset just controls that? Or am I trying to control the phone's volume from the headset? How does that work? You have to use set theory and type theory to define the relationships between these different volumes and what the rules are between them, so that the end user who's trying to control something doesn't have something too complicated, but yet they can still understand what they're doing, do something useful. It's the same thing with apps. You can't just pick either they're secure or they're useful, because if you try to make them secure, they tend to not be useful because they don't have access to anything. If you try to make them useful, they have access to too much, and then they have all your photos and all your private information. Well, there's ways to make that work. There's ways to have a sovereign control over data. There's ways to do it, but you have to understand how to break down the fundamental assumptions, the fundamental problems, and you have to attack those, because you can't solve these problems on the traditional assumptions. You have to start from the beginning, from first principles, as Elon Musk would call it. You have to use the first principles to solve these types of problems. And that's what this is. Parse Editor, it's a first principles problem that's being solved. And I just want to make sure it gets solved, but having to drive trucks for income just diverted my last 10 years. So let me know, you guys, if I could do a Kickstarter or do something to get this rolling, because I would like to make a software company that works on this specific problem. Peace out.